Okay, so there's the second part. So there's a mathematician who came after Huron, who was a Greek mathematician. So sort of think of him as being, I don't know exactly when he lived, but think of him as being back with Euclid and Aristotle, so 2,000 years ago, maybe even more. Brahmagupta was an Indian mathematician. Brahmagupta was an Indian mathematician who lived in the 600s. So a super long time ago. And this guy was absolutely incredible. He came up with amazing developments in math, even almost calculus, which was just astonishing. And so when you read about all the stuff he did, you just can't even believe it. But he came up with this incredible formula called Brahmagupta's formula for the area of a quadrilateral that can be inscribed in a circle. So not all quadrilaterals can be inscribed in a circle, but special ones can, and they're called cyclic quadrilaterals. And you know if you have a cyclic quadrilateral, what does cyclic sound like?
Sickle.
Sickle? Yeah. Where does sickle appear?
It's curved.
Oh, okay. Okay. Yeah. You heard of bicycle?
Yeah.
Yeah. So cyclic relates to circles.
So a square would be a cyclic quadrilateral.
A square is a cyclic quadrilateral. That is true. You know if a quadrilateral is cyclic if the opposite angles add up to be 180 degrees. That's how you tell if a quadrilateral is cyclic or not. But we'll get to this way down the road. But Brahmagupta came up with this formula. Area is, you define S the same way, the sum of the sides of a cyclic quadrilateral. And the area is the square root of S times minus A times S minus B times S minus C times S minus C. What do you notice that's different about this formula?
Well, you didn't need the S, just the S.
All by itself. And this is a very interesting formula. Now I don't know what quadrilaterals I can make that are cyclic, but actually I do know one. Actually, not important. So he came up with this formula, which is an incredible formula. It's an incredible achievement. Usually when you see this proved, it relies on trigonometry. I don't know how Brahmagupta proved it. But he knew a little bit about trigonometry, which is also amazing. But now, this is a more general setting. It's a quadrilateral instead of a triangle. How do you think this formula turns into Huron's formula? What happens?
Well, maybe if the S minus D, because we have the ABC already.
Yeah.
If the S minus D is S.
Okay, how would that happen?
If D is 0, so that it closes and they join to make a triangle.
Oh, how interesting. It turns out that the special case here that we were looking at before, that we didn't realize was a special case, is a special case of this situation that Brahmagupta discovered, where one of the sides, and we'll use D, I think that's a good idea, has length 0. But it's only a special case if we can always draw a circle around a triangle. Okay? So we're going to need to figure out how to do that. Okay?
All right.